Okay, well, let's just quickly think about this. Another standard one, I notice you have a picture of it in your book, so your book's going to explain it, but let me explain it the way it should be explained. Okay. First of all, in the XZ plane, it's an upward parabola, right? And we just do the slice. If y is 0, you got z equals x squared. That's an upward parabola. And in the yz plane, x is 0, of course, so it's a downward. Okay? So this should give us a result very quickly. Okay? I don't like the way the wording came out there. I said in the x equals y plane, this is the x equals y plane. X equals y is a plane, right? It's a plane where x equals y, so it's, you know, x here and y here. It's the vertical plane through that line at 45 degrees to the x and y axis, okay? You get a line in the xy plane, which is not the x equals y plane. The x equals y plane is a vertical plane in 3 space. The xy plane is this thing down here. So this thing intersects this thing and a line that is the part of the graph of the function. Okay? So the function is flat in that direction. Okay? Make sense? Okay, well, okay. So you get a picture of this. And then in any plane parallel to the xy plane, for any value z, x squared minus y squared has got to equal z, right? Okay, well, above the xy plane, that's going to be hyperbola opening in one direction. Below, it's a hyperbola opening in the other direction. So you can analyze this thing, and I'm not going to, you know, we've been there, so you should actually familiarize yourself with this function before we start bypassing any intuition about the graph by testing for critical points, right? Anyhow, okay, so we test for critical points. Fx equals, well, okay, 2x. I'm just going to cut that. But fy equals 2y.
Negative 2y.
Yeah. That's important. So it implies a critical point, right? Yeah, the origin again. Okay? Then fxy equals 2. Equals, of course, fyx, because they're always the same. The function's differentiable. That's very, you know, just take the x derivative, or the, that's what happens when I write things down too fast. This is fxx. And fyy is negative 2. And fxy is 0. And all those are very straightforward. So your discriminant is fxx fyy minus fxy squared, which is just 2 times 2 minus 0, 2 times negative 2, is negative 4. So again, you have a saddle point. Now that's obvious just from the fact that you have an upward parabola in the XZ plane and a downward parabola in the YZ plane, right? What's not obvious is when you have like upward parabolas or whatever in both planes, but somewhere in between, you got downward, okay? Or upward concavity in both the XZ and YZ planes, and a downward concavity kind of hidden from view if all you look at is the XZ and the YZ plane, right? In this FXY test, takes care of it. Okay? So it really, that's what you look at. That's a process. That's very simple. And the derivatives and the functions that are assigned are not terrible derivatives, okay? So these actually turn out to be fairly easy problems.